This is the first of two videos I'm going to do on decision tree analysis, which is one of the first numerical methods that you will come across in the A-level business course. And we're going to start with a brief description really of what a decision tree actually is. And we can say that a decision tree is a scientific approach, i.e. it's quantitative, it's based on numbers, and it shows the likelihood of outcomes and the consequences of outcomes which result from a business decision. So it's a very important model, a very useful model for managers to approach major decisions. So if we move this up and out the way a little bit, then we can start to actually look at it. So when we are drawing our decision tree, we start with the actual decision which the managers are going to make. So to represent a decision in our model, we use a square node. So this represents a decision being made by the managers. In other words, it represents a conscious action by the managers. Now, we're going to work through a little example where we're going to be using a marketing decision, and the options which are available to the managers, and each of these are represented by an arrow coming out of the decision, are to cut the price. They could increase advertising, but we also need to take account of the fact that that actually of doing each of those things, there is going to be an opportunity cost. So actually, we also need to think about what would happen if the managers were to do nothing at all. So whenever you're drawing a decision tree, you should always include a do nothing arrow, because if the payoffs from all of the other decisions are negative, then actually doing nothing might be the best course of action. So once we've marked on our decisions, the next thing that we need to do then is to mark on the potential outcomes from each of those decisions. And these are often simplified, and we use a circle to represent the fact that there are uncertain outcomes. So a square represents a decision, something that the managers can control. A circle represents an uncertain outcome, something which they cannot control. So for each of these courses of action, we will say that there are basically two possible outcomes. Either the business will do well and it will get a high level of sales, or it won't and it will get a low level of sales. And that is the same for the advertising as well. So when we've added those arrows on like that, we now have the basic structure of our decision tree which has been made. And of course, the do nothing doesn't have a degree of uncertainty, so we can carry that arrow right across like this. The next thing that we need to mark on then, we said before that these lines coming out of the circle nodes are uncertain events, and therefore we need some indication of how likely they actually are. So to do this, we think about the probability of each of these outcomes occurring. And we write that on the arrow. Now, we might gather this information from past experience. We might have some scientific data to back it up. But in any case, what we need is an indication of how likely these outcomes are going to be. And we write this information on the arrow like this. So what this means for the cutting the price here is that if I were to make the decision to cut my price, so I'm on this arrow here, then either I can have high sales or I can have low. And as I've drawn it here, the likelihood is that we will benefit from improved sales. So there is a probability value of 0.8 that we will get high sales, and a probability value of only 0.2 that we will get low sales. So in other words, what that's suggesting is that 4 times in 5 we will get a high return, and 1 time in 5 we will get a low return. Because these are the only two options, these two numbers must add up to 1. So if you are drawing this, then the total of all the probabilities coming off a circle node must add up to 1. For the advertising, we'll say that the odds are more even, and that there's a 50-50 chance in each case that we will end up with high and low sales. So now we've added on our probability. The next thing that we need to think about is if high or low sales actually occur, what is the outcome going to be? What is the payoff, in other words, going to be from that outcome? So we can say that if I cut my prices and I generate a high level of sales, then my payoff from that will be an increase in my revenue of £8 million. If I only get a low amount of sales, then my revenue will be 3 million. With advertising, it's a little bit more extreme. So with advertising, let's say there is a 10 million payoff if I get it right, and a 2 million payoff if I get it wrong. Now, it's difficult just by looking at that to figure out actually which decision is a better one to make, because looking at it, if we cut our prices, well, our payoff is lower, our best case payoff is lower, but the probability of us getting it is higher. And with our advertising, it's a riskier decision. The strong side, the positive side, is very high, but the negative side is lower. So the decision tree is what helps us to actually go through and to calculate which of these is going to be a better option. And to do that, we need to calculate the expected value of each of the decisions. So I need to calculate the expected value of cutting the price and the expected value of increasing the advertising. To calculate the expected value, what I need to do is a relatively straightforward calculation, which is I need to multiply the probability of outcome 1 by the outcome of option 1. And then I need to add on to that the probability of outcome 2 multiplied by the financial outcome of 2, and so on and so on. And I would do this for every arm that came off a circle node. Now, in this case, I've only drawn two nodes, so the expected value for me of cutting my price is the probability of option 1, which is 0.8, multiplied by the outcome of 1, which is £8 million, plus the probability of outcome 2, which is 0.2, multiplied by the probability of outcome 2, which equals 3. And when I perform that calculation, I get an expected value of £7 million. So I can say that on this one, I have expected value of £7 million as a result of cutting my price. When I do the same thing for, so this was the cut price option. When I do the same thing for my advertising, I get 0.5 multiplied by 10 plus 0.5 multiplied by 2. And when I've done those calculations, I find that the expected value of the advertising is 6 million. So that's what I'm doing here. So I'm calculating the expected value of these decisions. In other words, I'm trying to take account of the size of the payoff at the end of it and the probability of me getting those particular payoffs. Now, I'm nearly finished, but there is just one more thing that I need to think about, and that is the fact that it's likely that actually cutting the price and increasing my advertising won't be free. I will actually have to incur cost to undertake those decisions, and I need those to be reflected when I'm actually doing this calculation. Now, if I was to cut my price, then I'm going to have to incur costs in terms of changing my marketing materials and so on. So we will say that there is a cost of cutting the price of 1.5 million, which I will have to bear as a business. With the increase in advertising, though, that will cost me more because obviously I'm going to have to incur the cost of the advertising. So we'll say that one will cost me 4 million. Now I have all of the information that I need to be able to calculate which outcome is the most preferable in purely financial terms. So if we squidge this down a little bit, we have got the overall net gain. That's what we calculate at the end of this. So we've got net gains of cutting the price of the advertising and of doing nothing. Now the net gain of doing nothing is obviously 0. In this case, it doesn't change anything. For advertising, the expected value of the advertising outcomes was 6 million. I need to deduct from that the costs of making that decision, which give me the overall expected gain for advertising of 2 million. Cutting the prices, I take the expected value of 7 and I deduct the associated costs of making that decision, and that leaves me with a net gain of 5.5 million. And looking at this, it becomes quite clear that cutting the price is the preferred option here, because it's the option which results in the highest net gain based on the values that I've used here. So that's a quick work through of how to actually do a decision tree, how to draw one and how to populate it with information. It's unlikely, I suspect, in an exam that you would have to draw and populate and make a decision for the full decision tree, but it's quite likely that they may ask you to fill in the blanks, or to calculate one where the values have already been put in, or to use the valuations in order to make a decision. This is a very useful method, though, of breaking down a decision into its component parts and forcing the managers to think through all of the different aspects involved in their decision, and hopefully coming out with, as we can see here, a nice clear indication at the end of it of which decision is the most financially desirable.